Hello viewers, in today's session we are going to discuss another important problem from differentiability of functions, and in this class we are going to prove that this function f of x, which is absolute value of 3x minus 2, is not differentiable function at x is equal to 2 over 3, right? So here we'll show that this mod function mod of 3x minus 2 is not derivable at x is equal to 2 over 3. So let us see how we can prove the non-differentiability of this function at this point using the concept of right hand derivative and left hand derivative. So let us first find the right hand derivative of this function at this point. So the right hand derivative is defined by this limit h tends to 0, and we have f of a plus h minus f of a divided by h, right? Where a is this point, that is 2 over 3. Now the domain of this function, that is the mod function mod of 3x minus 2, is the set of all real numbers, right? And here now taking a is equal to 2 over 3, the right hand derivative is given by this limit f of 2 over 3 plus h minus f of 2 over 3, and here we have h, right? So now we can find out the value of f of 2 over 3 plus h by replacing x by 2 over 3 plus h in this function. So we have mod of 3 times 2 over 3 plus h minus 2, and here f of 2 over 3. Now f of 2 over 3 can be obtained by replacing x by 2 over 3. So we have mod of 3 times 2 over 3 minus 2. So here we have 3 and 3 get cancelled, so mod of 2 minus 2, that is a mod of 0, that is equal to 0. So here we have a 0, and here we have h. So now we can write limit h tends to 0, and here we have mod of 2 multiplying 2 over 3 plus h by 3, and here we have 3h, and here we have minus 2, and here we have h. Now 2 and minus 2 get cancelled, and we have limit h tends to 0, a mod of 3h divided by h, right? So now here we can make use of the definition of mod function. Now a mod of p is defined as a positive p when p is greater than 0. Mod of p is equal to 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0, right? Now see, here this quantity h is a positive quantity, and it is infinitesimally very small, right? Now since h is a positive quantity, so it implies that 3h is also a positive quantity. So mod of 3h is equal to positive 3h due to this part of the definition, because mod of p is equal to positive p when p is greater than 0. So here we can take p is equal to 3h. So mod of 3h is equal to positive 3h, because 3h is greater than 0, as h is greater than 0, right? So we have now limit h tends to 0, and here we have 3h over h, and h get cancelled. So we have limit h tends to 0. Here we have 3, and this is equal to 3, because this term is independent of h. right? So the right hand derivative of this function f of x at this point is equal to 3. Now let us find out the left hand derivative. So now the left hand derivative is defined by this limit h tends to a 0. We have f of a minus h minus f of a divided by negative h, right? Now a is 2 over 3, so we have a limit h tends to 0, f of 2 over 3 minus h minus f of 2 over 3, and here we have minus h, right? So now we have a limit h tends to 0, and f of 2 over 3 minus h can be obtained by replacing x by 2 over 3 minus h. So we have mod of 3 times 2 over 3 minus h, and here we have minus 2, and f of 2 over 3 is equal to 0, and here we have minus h. So now we can write limit h tends to 0, and we have here multiplying 2 over 3 minus h by 3. 3 and 3 get cancelled, so we have here 2, and then we have minus 3h, and then we have minus 2, right? And here we have minus h. So now here we can write limit h tends to 0. Now here this 2 and this minus 2 get cancelled, and we have mod of minus 3h, and here we have minus h, right? Now again using the definition of mod function, now here inside the mod function symbol we have a negative 3h. Now h is greater than 0, so minus 3h is less than 0, right? And now we have to make use of this part of the definition, that is a mod of minus 3h is given by negative of 3h, that is equal to positive 3h, right? Because here now the value of p is minus 3h, which is less than 0, right? So here we have limit h tends to 0, and mod of negative 3h is equal to here positive 3h, and here we have minus h, right? Now h and h get cancelled, we have limit h tends to 0, and here we have now 3 over minus 1, so we have minus 3, and this is this limit is equal to minus 3, right? So the left hand derivative is equal to minus 3, and the right hand derivative is equal to positive 3, right? And from this discussion we conclude that although the right hand derivative and the left hand derivative both exist and they are finite, but they are not equal to each other. That is, right hand derivative is not equal to left hand derivative, as 3 is not equal to minus 3, right? So this function is not differentiable at this point x is equal to 2 over 3, because for the differentiability of a function at a given point in its domain, the condition is that the right hand derivative and the left hand derivative both should exist, and they should be finite, and moreover they should be equal to each other, right? But in this case the right hand derivative and the left hand derivative are not equal to each other, that is 3 is not equal to minus 3. Hence we can claim that this function is not differentiable at x is equal to 2 over 3. Hello viewers, in today's session we are going to discuss an important problem from differentiability of functions, and here we are going to solve this problem where we have to prove that the function f of x that is equal to mod of x minus 1 minus mod of x minus 2 is not differentiable at x is equal to 1 and x is equal to 2, right? So here we have to show that this function f of x, which is the difference of two absolute value functions, two modulus functions. The first one is mod of x minus 1 and the other is mod of x minus 2, is not derivable at x is equal to 1 and x is equal to 2, right? Now see, the domain of this function f of x is the set of all real numbers, right? And this function f of x is continuous for all values of x belonging to the set of real numbers, right? Because we know that mod function is continuous for all values of x, right? So here this function that is mod of x minus 1 is continuous for all values of x. Similarly, this function that is mod of x minus 2 is also a continuous function for all values of x, and overall this function f of x is continuous for all values of x, right? Belonging to the set of real numbers. But this function is not differentiable at these 2 points, right? This function is differentiable for all values of x belonging to the set of real numbers except these 2 points, that is x is equal to 1 and x is equal to 2, right? So here we'll prove that this function is not differentiable at these 2 points with the help of the concept of right hand derivative and left hand derivative, right? So we'll find out the right hand derivative and left hand derivative for this function f of x at x is equal to 1, and then for x is equal to 2, and then we'll conclude that this function is not differentiable. Now let us start. So now let us first define the right hand derivative and the left hand derivative. So the right hand derivative is defined by this limit, that is limit h tends to 0. We have f of a plus h minus f of a divided by h, and here the notation may be taken as r for the right hand derivative, and then we have f of here a positive, right? And the left hand derivative is defined by this limit h tends to 0, f of a minus h minus f of a divided by minus h, and here we have L for the left hand derivative, and here we write f of a negative, right? So let us now prove the non-differentiability of this function at this point, that is x is equal to 1 and x is equal to 2. So let us first take this point, that is x is equal to 1. So here we'll now take a is equal to 1, right? So let us first find out the right hand derivative and then left hand derivative. So the right hand derivative is now given by a limit, and here h tends to 0, and remember h is an infinitesimally very small quantity and it is always positive, right? And here we have f of 1 plus h because a is equal to 1, right? And here we have f of 1 and here we have h. So now we have limit h tends to 0. Now f of 1 plus h can be obtained by replacing x by 1 plus h in this function. So we have here a mod of 1 plus h minus 1, then we have 1 plus h minus 2, and we can now find out the value of f of 1 separately here. F of 1 is given by mod of 1 minus 1 minus mod of 1 minus 2. So this is mod of 0, this is mod of minus 1, and this is 0. And here mod of minus 1 is 1. So here we have 1, so that is equal to minus 1, right? So here we have f of 1 as a minus 1, and in the denominator we have h, right? So now we have limit h tends to 0, and here 1 and 1 get cancelled. We have mod of h, then here we have mod of h minus 1, and here we have plus 1. Minus and minus multiplied together, it gives us positive, and here we have h, right? Now see, we have just said that h is infinitesimally very small, and h is a positive quantity. So now let us make use of the definition of a mod function here. So mod of p is defined as positive p whenever p is a positive number that is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0, right? Now see, here we have mod of h, and mod of h is simply equal to positive h, because h is greater than 0 due to this definition, right? And here we have a mod of h minus 1, right? Now see, h is infinitesimally very small, and it lies between 0 and 1. So this difference, that is h minus 1, is always going to be less than 0. That is, this quantity is always going to be negative, right? So due to this definition, that is mod of p is equal to negative p when p is less than 0. So here we can take p as h minus 1, and h minus 1 is negative, that is, it is less than 0. So mod of h minus 1 is now equal to, due to this definition, we have negative of h minus 1, right? So we can now write here minus h and plus 1. So here we have now limit h tends to 0. Mod of h is simply positive h, and here we have negative of mod of h minus 1, which is equal to 1 minus h, right? So here we have 1 minus h plus 1 over h. So this is limit h tends to 0, and here we have h minus 1 plus h plus 1 over h. Now minus 1 and 1 get cancelled. We have limit h tends to 0. This is 2h over h. H plus h is 2h over h. H and h get cancelled. We have limit h tends to 0 and 2, right? And now this expression is independent of h, so the limit is simply 2, right? So the right hand derivative of this function at x is equal to 1 or a is equal to 1 is given by 2. So here we write the right hand derivative equal to 2. Now let us find out the left hand derivative. So now the left hand derivative is given by limit h tends to 0, f of 1 minus h. So we have 1 minus h, and here we have f of 1 divided by minus h. So we can now write limit h tends to 0. F of 1 minus h can be obtained by replacing x by 1 minus h. So we have a mod of 1 minus h minus 1. Then we have here 1 minus h minus 2, and f of 1 is minus 1. And here we have minus h. So let us simplify this expression. So here 1 and minus 1 get cancelled. So we have mod of minus h, and here we have mod of minus h minus 1, right? And here we have plus 1, and here we have minus h, right? So now let us once again make use of this definition of mod function. Now see, here we have a mod of minus h. Now h is a positive quantity, so negative h is less than 0, right? Because h is a positive quantity, right? And minus h is less than 0, that is minus h is negative. So due to this definition, mod of p is equal to negative p. So mod of minus h is equal to minus, and here we have minus h because p is minus h. So this is plus h. And similarly here, mod of minus h minus 1 is given by negative of minus h minus 1, because this quantity, that is minus h minus 1, is a negative quantity, because here h is positive, right? So again, due to this definition, we have mod of minus h minus 1 is negative of p. P is minus h minus 1. So here we have plus h plus 1. So now we have limit h tends to 0. Here we have simply h, and then we have here h plus 1 plus 1 over minus h, right? So now we can write limit h tends to 0, and here we have h minus 1, and here we have plus 1, and here we have minus h. Now we can see that the numerator is 0, because h and minus h get cancelled, 1 and minus 1 also get cancelled, and here we have 0 over minus h, that is equal to 0, right? So the left hand derivative is equal to 0, right? So now from this discussion, we have seen that the right hand derivative is 2 and the left hand derivative is equal to 0, and the right hand derivative is not equal to left hand derivative, that is 2 is not equal to 0. So this function f of x is not differentiable at x is equal to 1, because for a function to be differentiable at a given point in its domain, the right hand derivative and the left hand derivative both should exist, and they should be finite, and moreover they should be equal to each other. But in this case, the right hand derivative is not equal to the left hand derivative, that is 2 is not equal to 0, right? So the function is not differentiable at x is equal to 1. So now let us consider this point, that is x is equal to 2. So now consider this point, that is a is equal to 2. So now the right hand derivative is given by limit h tends to 0, and we have f of 2 plus h minus f of 2 divided by h. Now let us first find f of 2. So f of 2 is it can be obtained by replacing x by 2. So we have mod of 2 minus 1, and then we have 2 minus 2. So mod of 2 minus 1 is mod of 1, here mod of 0, and this is 1 minus 0, that is equal to 1. So f of 2 is equal to 1, right? And here we have limit h tends to 0. F of 2 plus h can be obtained by replacing x by 2 plus h. So we have mod of 2 plus h minus 1 minus 2 plus h minus 2, and here we have f of 2, that is 1, and here we have h. So now simplifying this expression, we have mod of this is 2 minus 1 is 1, 1 plus h minus 2 and minus 2 get cancelled, and we have here h, right? So now again here we have to use this definition. So mod of 1 plus h is simply equal to positive 1 plus h, because h is a positive quantity, 1 is also a positive quantity, so 1 plus h is always going to be a positive, right? And due to this definition, when p is positive, p is greater than 0, mod of p is equal to a positive p. And similar is the case with mod h, and mod h is equal to a positive h because h is a positive quantity, right? So now we have here limit h tends to 0, and here we have simply 1 plus h, here we have simply h and minus 1 over h, and here 1 and minus 1 get cancelled, h and h get cancelled, and we have limit h tends to 0, and here we have 0 over h, and that is equal to 0, right? So the right hand derivative of this function at this point is given by 0, right? So now let us find out the left hand derivative. So now the left hand derivative is defined by this limit h tends to 0, and here we have f of 2 minus h minus f of 2 divided by minus h, right? And we can now write limit h tends to 0. F of 2 minus h can be obtained by replacing x by 2 minus h. So we have mod of 2 minus h minus 1, and then mod of 2 minus h minus 2, and here we have f of 2 that is equal to 1, and here we have minus h. So let us simplify this expression. So we have 2 minus 1 is 1, so we have 1 minus h, mod of 1 minus h, and here minus 2 and 2 get cancelled, and mod of minus h, and here we have minus 1 over minus h, right? Now let us consider mod of 1 minus h. Now again, due to this definition, now see 1 minus h. 1 minus h is going to be a positive quantity because 1 is greater than h, right? And h is a positive quantity. So 1 minus h is always going to be positive. That is 1 minus h is greater than 0. So mod of 1 minus h should be equal to positive 1 minus h. And here we have mod of minus h, and mod of minus h is simply equal to here a negative of h, that is positive h, because h is greater than 0 but minus h is less than 0. So here minus h is less than 0. So due to this definition, mod of minus h is equal to a negative of p. So negative of p is minus h. So we have positive h. So now we can write here a limit h tends to 0. Mod of 1 minus h is simply 1 minus h, and here we have mod of minus h is simply h. So here we have h and minus 1 over minus h. So we can now write limit h tends to 0, and here we can see that 1 and minus 1 get cancelled, and minus h and minus h, it becomes minus 2h, and here we have a minus h, right? And here negative and negative get cancelled, h and h get cancelled, and we have limit h tends to 0, and here we have 2, and this term is independent of h, so here we have simply 2. So the left hand derivative of this function at x is equal to 2 is 2, right? So here we conclude that although the right hand derivative and the left hand derivative both exist and they are finite, but they are not equal to each other. That is, a right hand derivative is not equal to a left hand derivative. 0 is not equal to 2. So this function is not differentiable at x is equal to 2, right? So viewers, this is how we can prove the non-differentiability of this function at these 2 points.